If you're looking to develop new skills, then watching online training videos is great, but it can only take you so far. In this video, I'm going to go over 4 pro tips to accelerate your progression. I'm also going to give an example of how one of my students is applying these principles, which makes it a lot easier to get help from me personally. If you're new to this channel and you're keen to learn the latest tips, tricks, and tools for working more effectively with data, please hit the subscribe button for weekly videos. 4 pro tips that will massively accelerate your progress. 1. Get specific. There are far too many things to learn everything. One of the most important skills you can learn is defining the scope of what you want to achieve. For example, your first project may be to replace some analysis done in a spreadsheet. Learning deep learning is interesting but not relevant. Apply what you've learned to real-world problems. Real-world problems are different to homework assignments. A real-world problem should be the reason you're studying something in the first place. These days, where everything can be looked up on Google within a few minutes, the real skill is being able to effectively filter the relevant information and adapt the solution to work for your problem. Break down the problem into small chunks. Big complicated problems are the composite of lots of small problems. And as the saying goes, the only way to eat an elephant is one bite at a time. Get feedback on your work. The sooner you can get feedback, the sooner you can progress. Feedback is a critical step of progression because unless you can identify what needs to be improved and how to do something properly, you can easily keep repeating the same mistake for years. Learning how to ask for feedback is also key. And so in the next section of this video, I'm going to go through a question from one of my students so you can see a great example of a question that 1. Demonstrates you have done the work. 2. Clearly explains what you need. 3. Is respectful of an instructor's time. 4. Allows an instructor to give you feedback on things you didn't even know how to ask for. So I have this question from one of my students, Luis Ferrolante, who's on my course R Tidyverse Reporting and Analytics for Excel Users. And I really love this question, not just because it addresses some things that are very, very common across a lot of different students, but because he's asked this question in a really great way. Now, he's asked me a question effectively to do with how to rename some columns in the latest standards of R. He's also sent me a nice, concise piece of code here with some comments showing me what he's tried and what results didn't occur for him and what he's tried to resolve these kinds of issues. And so this is really helpful to be able to see a student's piece of code because it allows me to address much more than just a media question. I can also give Lewis a lot of feedback on how he can improve his code to make it better and help him understand things that he might not have necessarily picked up on his own. This is something that really helped me out a lot when I was getting started. I had a lot of these same types of questions, and if I didn't have a friend who helped me through a lot of these myself, I probably wouldn't have made as much progress, or at least not as quickly. So this is something that I think can really help out a lot, and if this is something that you feel would help you out as well, I'd love to be able to do this for you. Just so check out some of the links I have below for the courses that I run, and I'd love to be able to help you out with these kind of things. So in this question here, we're basically looking at how to rename some columns using the Tidyverse standards of R. And let's go through this code. I'm just going to do a few quick cleanups here. So I'm really glad that there's only 32 lines of code here, because sometimes students do send me, say, hundreds or maybe even thousands of lines of code. And that's really just not practical for me to review in a course. But if you're asking me very specific questions about a specific thing, then it's very easy for me to kind of review try and understand what you're doing, and get to exactly what you need. So he's got the Tidyverse library here, so that's a good start there. And Tidyverse, I'm just loading this up right now, actually includes a bunch of built-in libraries. Now, normally when you load this, I must have loaded this already, this actually shows you the packages that it actually loads along with it. So let me actually restart R so that you can see that. So I'm just going to go to session and I'm just going to restart R. Okay. And you can see when I load up the Tidyverse library for the first time before it's been loaded, it actually has a bunch of libraries already included in it. So the first one of these libraries that's included in here is actually ggplot2. Now this is the plotting library, which is basically used for creating charts and graphics. So we don't actually need to include this line of code here. So we can cut that down and make this a little bit shorter. We have other important libraries here like Tibble. So this is, a Tibble is basically the new generation data frame. So we'll go over this because this is actually really relevant to this question as well. Now I've got these two lines of code. These are basically duplicated. So for the purpose of asking a question, it's best just to have one of these here so that I know which data set that we're dealing with. So we can see that the actual code operates on this, this second data frame. So I'm just going to delete this first one. So I'm going to get rid of that there. And I am going to get rid of that there. Okay, so we've got read_CSV. Now this comes from the readr library. And I'm glad to see that he's using this version of it. Because again, base R has a version of this called read.csv. And it's really, really subtle. But the difference between this is that read_CSV loads a Tibble, which is the newer next generation data frame. Okay, so this is why I want to point this out, because this line of code here, data.frame, basically what this does is this converts our new Tibble object back into an older style data frame. This is known as typecasting, and the reason why we don't really need it here, but the reason why you would want to do this in some situations is because of backwards compatibility. So there is a handful of times, not very many, if you are using older libraries for R, then the newer type of data frame, the Tibble, won't work with the older libraries because of minor syntax changes. Now, 99% of the time, whether you use a data frame or a Tibble, it's still going to work just fine, right? But to keep it short, you don't need this line of code here. So I'm going to cut that out as well. So I'm going to run this and I'm going to load up a CSV file. So I've just created this file, duplicate columns, and you can see here that it has red in the columns. It's got two columns named type. And it has automatically renamed one of these columns type_1, right? So I'm just going to change this piece of code here a little bit, and that's going to be type, and that's going to be type1, right? So again, when you're putting together examples, you can use very, very simple examples. They don't have to be complicated. Okay. Now, over here, we have this line of code, and we can see here that this renames these columns, right? The trouble that he's having here is that when he looks at this table again, right, and runs that here, the names are still type and type1. So the problem he's having is that these name changes haven't been made permanent. They haven't been saved. Now, this is actually a really beneficial feature, and hopefully as we go through this, you'll start to understand why. Now here, what he's done is that he's figured out a base R solution. Now, there's a couple of comments I want to make about this. So first of all, he has used static column numbers, so he's used column references. And one of the problems with this is that if you have any changes in your data, then these things will break, right? If the column moves, which is very, very easy to do. Say you run a database query and then you update that query to include a new column, a feature that you left out the first time, then these kind of references, these column references are very fragile and they will break. But the reason why this works is because we have the assignment operator here. So the assignment operator basically saves these. And so it writes over the original data frame. Now, let me get rid of these bits of code here. We don't need those either. If we wanted to overwrite the original data frame, then basically the only thing we would need to do is stick this in here and we could assign these results back to that data frame. But here's why you typically don't want to do that. When you overwrite the original data frame, it's very difficult to make subsequent changes. So we know that when the data is loaded, it always comes in as type and type_1. And so if I run this the first time, it works because it's renamed these columns. But if I run this again, it doesn't work, right? Because object type is not found, right? Because we've changed it. In order to get this to work again, we have to reload our data. So I have to come back all the way to this line and I have to come to here and I need to reload our data. Now, a lot of times loading data, especially with bigger data sets, is one of the slowest parts because it has to read the data from disk. So that's hard drives. You know, if you have a solid state drive, this is a bit faster. Oftentimes this is going to be loading off a network, which is 1,000 times fast, 1,000 times slower than a hard drive. And maybe you're even loading these files over the internet, which was going to be like 1,000 times slower than a network connection. So if we can reduce the number of times that we load data, it's really going to save a lot of time. So here, I don't want to do this, right? Now, a workaround that people often do is they will maybe make a version 2. Okay, so they will, instead of overriding the original data set, they'll create a new one. And so now we have this version of the data frame, which is kind of the original one. And then we have another version of the data frame, which is version 2, right? The question is where does this end? Because usually in data, you need to do lots and lots of different steps. You have lots of different transformations on your data. And are you going to make a version 2, a version 3, a version 4, a version 5? It just goes on and on, right? So, you know, do you override your original data or do you make lots and lots and lots of different versions of it? So effectively what piping allows us to do is that it allows us to do lots of different steps and easily go back and change those steps before we decide to actually save those results. So here, okay, I've got one change done off the original data set. If I want to add another change in here, so let's say I pipe this again, so Control-Shift-M shortcut key for that, and I want to add a column. So if you're on my course, you would have learned about the mutate function, which is used for adding columns. So I could create a new column called, say, product, and product is equal to the shipment kind times the container type, right? So there's my next step there, right? And so I could do that, right? And you can keep on adding lots and lots of different steps to this without affecting the original data set. And this is actually really, really useful. So if you found this video helpful, please leave a thumbs up. If you would like my help with these kinds of problems, I would love to be able to help you. And do take the chance to check out some of my courses in the links below. Anyway, thanks for watching, and I will see you next time.